For 5.2, a few key terms that you'll be introduced to. The factor theorem, relative maximum, which is going to be a point on the graph that's roughly the highest part in the area, in the nearby vicinity. So this point right here would be considered a relative maximum. We'll see multiple zero, relative minimum, which is kind of the same bit that we had going here. Let's make that a little bit more curved. But now the relative minimum is the lowest point that's in between two areas. We'll also see multiplicity, which is going to be considered the small little exponent that we occasionally see sometimes above a binomial. We'll see all of those. If you want to read through this description, go for it. But the main thing to take away from this section is that we're still finding zeros, which is another way of finding solutions, which is another way of saying x-intercepts. We've been working for this for a little bit. We did this towards the end of chapter 4, saying that x equals some number. And we've worked with this previously by factoring, using diamond method. We've also seen completing the square. We've also seen quadratic formula and all that. We've also graphed, and with this section, we're still working with polynomials. We're still working with that same idea, and we're going to do the same things that we've been doing with factoring, completing the square, and all of that. But now with polynomials, this can sometimes be a little bit more tedious with the factoring. So we'll take our time. We'll fall back on diamond method and anything else that we've done along the way. So going for the factored form of x cubed plus x squared minus 12x. I know that this is in standard form because 3 is the highest exponent of the three terms, so I definitely know that this is cubic, but what we're being asked is to go to the factored form. So I know that these three terms have x in common, so I know that if I take that out, that would get me to x outside parentheses with x squared plus x minus 12 inside. This looks as if this can be factored further as a trinomial, so let's try that. We have diamond method to set up with negative 12 as our product, positive 1 is our sum. The only numbers that make sense here are 4 and negative 3. So we can factor this trinomial further and say that this is still x on the outside, but now with x plus 4 and x minus 3 on the outside. And we're done. I'll give you a moment to try the next one. Same kind of thing, factor out x, you have x squared minus x minus 12. Slightly different here with your factors, but this should now be x minus 4, x plus 3, and x is still around the outside, round the outside. So we want to keep that. That's considered the most factored form. Factoring this way is really extensive, but it's going to be really important, especially as we start to pinpoint, what we've already seen with polynomials with roots and zeros and x-intercepts. Now, just based off of factored formats, we'll be asked to find the zeros. The steps on the right here are going to be able to help you out. So what we're doing first, as far as when we're graphing these, is going in this order. We've already had this factored, so we're kind of good there. I think I'll kind of write that in first. So factor first. We're then finding the zeros of the function. How can we do this? We have these factored pieces here, factors. If we set each of these equal to 0, that'll give us 1, 0. This will give us a second. Finally, the last factor we have is x minus 1 equals 0. When we solve all of these will tell us what zeros we have. So we can just add 3. We now know that when x is 3, this is a 0. If we solve for x in this problem, when x is negative 4, this is a 0. If we solve for this last one, when x is positive 1, this is a 0. So we have 3 zeros. So let's make a note of that. So our zeros are at the following. They are at positive 3, negative 4, and positive 1. So this step's done. Determine the end behavior. You learned about this in 5.1. So we know that if this was all pushed together, we would eventually have a term that starts with x cubed. If you're not convinced, you can FOIL all of this out. Take two of the products or two of the factors, multiply, and then multiply the last bit. But this is definitely going to have x cubed. So we can imply that this is going to be going down to the left, but going up and to the right. There may be a turn or so. But let's sketch out what we have so far. So we know that if we're sketching this out, we know that there's a 0 at 3. So we know that this definitely hits here. We know that if x is -4, that hits here. We know that if x is 1, that hits here. So we've sketched out a little bit of what we've done. So we know the end behavior is going to go down and to the left, but up and to the right. So this is the end. This was how we got the zeros. Now we're being asked to find the values for x between the zeros and then sketch this out. So some values that we have in between. Well, I know that if x is 1, we don't have anything here, so we'll probably need to, or sorry, when x is 2, we don't know what that is. So let's try and see if we can find exactly where this goes. So if x is 2, the arithmetic here, you can kind of stream, like you can run right through this when you're really good, because if you plug in where x is 2 is here, this is going to be 2 minus 3 multiplying with 2 plus 4. Multiplying with 2 minus 1. So 2 minus 3 is -1. 2 plus 4 is going to give you 6. 2 minus 1 is 1. So the outcome when x is 2 is -6. So this is a bit of information that's given to us. So let's plot this. So we know we've got this. We also can say that as far as the turns go, there's going to be 2 or 0 turns. So that's something you could also consider. So we've got this point. We can assume that this goes like this. So maybe there is 1 turn. And let's go back and let's find some points that are in between here and here. So let's just go for the gut. Let's go right in between. This is going to be when x is -2. So let's get this. I'm going to kind of jump ahead on the arithmetic here. So if we plug in where x is -2, -2 minus 3 would be -5. If we plug in where x is -2 here, this would be -2 plus 4, which is +2. Finally, -2 minus 1, which is -3. So the arithmetic here would actually be +30. So what does this mean? We can plot this out. Yeah, that makes sense. When x is -2, the outcome's 30. We just did that arithmetic to get it. So that would be like way up here. So let's say that this is now -2, +30. Good. Yeah, we're good on that. So we know from the end behavior that this is going to go up and then kind of swing down and then go to the right. So it's coming up from the left, it's curving, it's going like this. We then swish around. This is going to keep going. So these are tedious, they're time consuming, they take a little bit of work, but if you follow the steps, I'm confident that you'll be successful.